Record. Okay. Um, let me go over the complex numbers thing again. Not super whiz bang important, but you are going to see it from time to time, and it probably will be on the final exam. And we know that the square root of 16. What that means is, excuse me, what number times itself? What number times itself is 16? Well, it's plus or minus 4. We have to say plus or minus because 4 times 4 is 16, and negative 4 times negative 4 is also 16. Right? Right. Now, we have to have a way of dealing with, now up until now, if we said the square root of negative 16, we said was undefined. But we have to have a way of dealing with this because we say this is undefined because nothing times itself is going to be negative 16. Negative 4 times negative 4 is positive 16, and blah, blah, blah. Okay? So up until now, we said this was undefined. Now what we do is we know that I squared is negative 1. This is semi-important. And the square root of negative 1 is I, frontwards and backwards. And we have to have a way of dealing with this. I think.
Professor?
Uh-huh.
Sorry to interrupt, but are you recording?
Yes, thank you.
Great.
Yep, thank you. I remembered. One time in a row. Okay, so my uncle was an electrical engineer, and he went off and died on us. But I think this has something to do with electronics and like that. I don't know. But anyway, so if we have the square root of negative 25, up until now we would say undefined. But we can factor this into the square root of negative 1, which we know is I, times 25. And again, now we can break this down into the square root of negative 1 times the square root of 25, or you can leave it under the same radical. It doesn't make any difference. Now we know that the square root of negative 1 is I, and the square root of 25 is 5, which we typically would write 5i. If you have a negative, I tell you, it really gets down to this. If you have a negative under the radical, square root of, say, negative 36, just bring the I out, and then the number under there will be positive, so this would be 6i. Everybody got it? It's really pretty simple. Now, if we had this, the square root of 48 divided by the square root of 3, I'm so stupid. Negative 48 and negative 3, I'm sorry. We can put it all under one radical, negative 48 over negative 3. So we have the square root of negative 48 over the square root of negative 3. Okay, now when we have negatives on the inside of the radical, we can just bring out an I. Now I you can think of as a number. I divided by, excuse me, I divided by I is 1. So we can just eliminate that. And 48 divided by 3 is the square root of 16. Okay, 48 divided by 3 is 16. So this equals plus or minus 4. I'm not going to be real wild about this plus or minus misery, but you are going to find somebody along the line, an instructor, who is going to be concerned about that. Now, solving quadratics, if we have x squared plus 4x plus 3 equals 0. Okay, what we do is we factor this into x plus 3 times x plus 1 equals 0. And now what we do is we set each one of these factors, equal to 0. X plus 3 equals 0, and x plus 1 equals 0. Subtract 3, x equals negative 3. Negative 1, and x equals negative 1. Okay, now what happens here is, if you have your handy dandy graphing calculator, you can put this in there, and you're going to get a parabola. A parabola happens when you have an x squared here, and it's going to come down kind of like that. Negative 1 and negative 3. Wherever the parabola crosses the x-axis, this is the x-axis, wherever the parabola, am I talking too fast? Please tell me if I am. Say, slow down, boy. Okay, wherever the parabola crosses the x-axis, those are the solutions. Now, if you put negative 3 into this, it's going to equal 0. Negative 3 squared plus 4 times negative 3 plus 3. Does that equal 0? Negative 3 squared is 9 minus 12 plus 3. 9 minus 12 is negative 3. Does that equal 0? Well, 9 and 3, we can do that. 9 and 3 is 12. 12 minus 12 is 0. So 0 equals 0. So it is correct. And you can do the same thing with negative 1, and it'll come out the same way. Now, if you use your handy dandy graphing calculator, first thing you do is turn it on. Then you go to y equals, it's right up here, y equals, and then put in x squared. Now, x is not this. This is multiply. X, the variable x, is this one right up here underneath mode. It says x, t, theta, and n. So we have x squared plus 4x plus 4x plus 3. Before you leave this screen, double check up here that you put it in correctly. Mr. Jimenez, you have big fat fingers. You ladies, y'all have long fingernails. You're going to hit the wrong keys. It's going to happen. You got to have fingers like a spider to work this thing. Now we go to graph. And you can see it crosses the x-axis at negative 3 and negative 1. Those are the solutions. Now we have 3 possibilities with quadratics. 3 possibilities. P-O-S-S-I-B-I-L-I-T-I-E. 3 possible things can happen with a quadratic. You can have, like we had here, 2 solutions. 2 solutions. You can have 1 solution where it comes down and just touches. That's called a tangent. It just touches in one place, so you only have 1 solution. Or you can have no solutions, where the parabola does not cross the x-axis. So there's two solutions, one solution, or no solutions. Okay? Okay. Mm-hmm. 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 Okay. What if we have this? If we have x squared minus 25 equals 0. What do we have here? A conjugate. Okay, y'all need to snap to this. It's the difference means subtract, excuse me, the difference of two squares. And what we get here is x plus 5 times x minus 5 equals 0. Okay, we're going to use this conjugate misery more and more. So you need to snap to the fact that I've got a fly in here. I don't know where that came. Hope it's not a mosquito. I hate mosquitoes almost as much as Yankees. Okay, so what do we do here? We set each one of these factors equal to 0. X plus 5 equals 0. And x minus 5 equals 0. Subtract 5, subtract 5. So x is negative 5. And here we're going to add 5 to each side. And x equals 5. Oh, in your college class, are y'all using this conjugate misery and factoring and whatnot? Y'all awake? No?
Yeah, I think we used it like the first classes.
You did? Okay. Yeah, this
Yeah.
is semi-important here. Now, what if we have this? If we have x squared equals, remember, we always is a long time, but we typically want to set these equal to 0. And then factor them, and then set each one of the factors equal to 0. So if x squared equals 16, again, we want to set this equal to 0. So we subtract 16 from each side, and we get x squared minus 16 equals 0. And what do we have here? The difference of squares. So this is a conjugate. So this is x plus 4 and x minus 4 equals 0. So our two solutions here are negative 4 and positive 4. Mm-hmm. You can get this if you're so smart. What if we have this? A squared equals negative, come on boy, think, 36. Excuse me. Again, we want to set this equal to 0, so we're going to add 36 to each side. And we get a squared plus 36 equals 0. Now, what are the factors what are the factors of this?
Doesn't have factors.
I'm sorry?
It's a prime number, so it doesn't have.
Exactly. Excellent. Very good. This is prime. This cannot be factored. Remember, the only ones that can be factored, conjugates, are if it's the difference of two squares. This is prime. And what does that mean? There are no solutions to this. And if you graph it, it's going to cross the y-axis at 36, which is way the heck up here, and will not cross the x-axis, so that's prime. Mm-hmm. Okay. Evaluating rational expression. Sounds like a disease, doesn't it? Okay, rational expressions are things that can be shown as a fraction. For instance, 2/3, 5/8. Is pi a rational expression? No, because it cannot be shown as a fraction. What's another one? It doesn't make any difference. So what if we have this? If you're given 3x plus 6 over 2x minus 4. Now what we want to do is evaluate evaluate for x is 3. This is real simple. All we want to do is, looks complicated, doesn't it? It's not. It's real easy. Wherever there's an x, we're going to plug in 3 and reduce the fraction. First, we're going to do the arithmetic. So wherever there's an x, we're going to plug in 3. So we have 3 times 3 plus 6 over 2 times 3 minus 4. So that now we just do order of operation. Now remember, the fraction bar kind of acts like parentheses. The numerator and denominator are in parentheses. So we have 9 and 6 is, what is it, 15? Over 6 minus 4 is 2. Can this be reduced? No. Now the one thing that you have to watch for is you cannot have the denominator. Remember, the denominator is the one on the bottom. Minator. You cannot have the denominator equaling 0. Because if you forget this, put it in your calculator. You can do this. Like if you had 0 over 5. First you turn it on. And you push 0 divided by 5 is what? 0. What does this mean? It means how many 5s are there in 0? Well, there are none. However, if it's backwards, if you have 5 divided by 0, you're going to get an error message. 5 divided by 0 is, what does it say? Math error. Because what does this mean? How many nothings are there? How many nothings are there in 5? Well, it doesn't make sense. It's just stupid. So this is, you cannot have 0 in the denominator. And we're going to talk about that more. Let's see. Let's use the same fraction, the same rational expression, 3x plus 6 over 2x minus 4. Evaluate. Evaluate for x equals 0. So again, wherever there's an x, we're going to plug in 0. So 3 times 0 plus 6, and 2 times 0 minus 4. 3 times 0 is 0, plus 6 is 6. 2 times 0 is 0, minus 4 is negative 4. So our answer here is negative 3 over 2. Okay? Now, Determine when a rational expression, R-A-T-I-O, rational expression is undefined. Undefined is any number over 0. When you get 0 in the denominator, you got undefined. Okay, at some point, all rational expressions will have an inconsistent solution, or you can say an undefined solution. Now, this is very, very simple also. It just sounds hard. Okay. Now, we cannot have 0 in the denominator. So what are we going to do? We're going to take the denominator and set it equal to 0. Okay. So we're going to add, add 4 to each side. 2x equals 4. Divide by 2. X is 2. Cannot have 2 as our answer here, because if you plug it back into the denominator, in the numerator it'll be okay, it doesn't make any difference. But we cannot have 0 in the denominator. So if we put 2 in, 2 times 2 minus 4, 2 times 2 is 4, 4 minus 4 is 0. So we cannot have this. Okay? We're going to have that. Now if we have x plus 5 over 3x plus 2, determine where the rational expression is undefined. So all we do is we take the denominator, 3x plus 2, and set it equal to 0. Subtract 2, subtract 2, 3x equals negative 2, divide by 3. X cannot equal negative 2/3. Because if you put 2/3 in here, you're going to get negative 2 plus 2 would be 0. You can't have that. This makes sense? Okay. Okay. Here we're going to write the rational expression, THENAL. Well, my handwriting's getting worse. XPRESSION. Write the rational expression in lowest terms. Okay. Now, what if we had this? If we had 4x plus 6 over 2, can we reduce this? Yes. Now remember, if these are not in parentheses, we have to divide each one of these terms by 2. So this is 4x divided by 2 plus 6 divided by 2. Have to divide each one of the terms by 2. And we get 2x plus 3. Okay? This is where you want to stop and take a drink. Oh, that's good. Now what if we have this? What if we have AB divided by CB? This is all multiplication here, so we don't have to divide each term by one of these. So b divided by b is 1, so our answer there is A over C. Okay, y'all get the idea here. If there's a plus or a minus in here, that makes this an expression. And you have to divide each one of the terms in the expression by the denominator. Here, this is a term. AB is a term. So we don't have to divide each one of them. Okay, so what if we have this? $14 b squared over 2b cubed. Okay, now we can do 14 divided by 2. We can do this, 14 over 2 times b squared over b cubed. Because there's not a plus or minus in here, each one of these are terms. So 14 divided by 2 is, 7. Now, b squared divided by, b cubed. If you don't remember, I think we did this earlier in the year. B squared is b times b. B cubed is, this is a 3 here, b times b, come on, stupid, times b. Okay, any number divided by itself is 1. So this is, we can put the 7 in the numerator, 7 over b. Or you can put it out front, doesn't make any difference. 7 times 1 over b. But this is typically how we're going to do it. Okay? Excuse me. Okay, what about this? Get this if you're so smart. 3a minus 12 over 5a minus 20. Okay. Let's factor the numerator and denominator. What can we factor out of both of these terms here? 3, right? A minus 4. Is that right? 3a minus 4. Yeah. Over. And what can we factor out of here? 5. Open. A minus 4. Now 5/3, that's a prime. Those are primes, so we can't do anything with that. So it's going to be 3 over 5. A minus 4 divided by a minus 4 is 1. Any number divided by itself is 1. So this is our answer. Everybody okay? I'm falling asleep? This is fun stuff here, huh? Just what you want to do on a Tuesday night. Okay, let's see you get this if you're so smart. 2y a la 2 menos 8. I don't know what any of that means, but it sounded Spanish. And in the denominator, we get 2y más 4. Right? Am I right or am I right? I'm right. I'm always right. Miss Cedillo's rolling her eyes. I can hear it from here. That boy's never right. He's stupid. Let's drink. Oh, that's good. Okay. Let's factor the numerator. What can we factor out of this? 2y squared minus 4. What jumps out at you there? It's a conjugate, right? Y squared minus 4 is a conjugate. And what are we going? What can we factor out of the denominator? Again, a 2. Open y plus 2. Now we need to factor this conjugate here. Now 2 divided by 2 is 1, so we can just cross that one out right away. The conjugate here is y plus 2 times y minus 2 divided by y plus 2. Okay, now we can cancel those out, and our answer here is y minus 2. These are really not difficult, they're just kind of involved a little bit. Let's see, what else? Now this is about as difficult as these get, and it's not really very difficult. If we have m squared plus 2m minus 8 divided by 2m squared minus m minus 6. Can we factor out these m squareds? No, because there's pluses and this is not one term up here. This is an expression. So what are the factors of this? Remember when we have a negative here as the constant, we're going to get m plus some number times m minus some number. Now what are the factors of negative 8 that combine together to give us a positive 2? Negative 8. Let's see. 1 and 8's not going to do it. 2 and 4. Positive 4 times negative 2. That's it there, isn't it? Negative 2. Positive 4. Is that right? I think so. Now, what can we factor here? Now remember, if the leading term here is not 1, we have to multiply 2 times negative 6 is negative 12. Now what are the factors of negative 12? That are going to give us 1. What's it going to be, 3 and 4? 3 times negative 4. Now remember, what we want to do here is we're going to split this linear term. We're going to split it up into these. Now which one do we want to put next to the 2m squared? The 4, right? Because they're factors. Minus 4m plus 3m minus 6. Everybody with me here? Okay. Now we group those two together. So what can we factor out of this one? 2m. Oh, am I running out of ink? 2m oops, sorry. 2m times m minus 2. Is that right? 2m times m is 2m squared, right? 2m times negative 2 is negative 4m, that's right. And what can we factor out of here? 3, open, m minus 2. And remember, these two must be the same. So our factors are 2m plus 3, m minus 2. So what can we factor out of numerator and denominator? We can factor those out, and we end up with m plus 4 over 2m plus 3. Is there anything else we can do here? Can we factor anything out of here? No. Okay. What fun is that? Okay. Let's do one more and I'll let you go. I know y'all are tired. So what if we have this? This if you're so doggone smart. X squared minus 7x plus 10 over 3x squared minus 75. Okay, we want to find the factors of 10. Now remember, when the linear term is negative and the constant is positive, it's going to be x minus something and x minus something. Because the last thing we do in distributive property is this one times this one, negative times a negative is a positive. So what are the factors of 10 that add up to 7? Was it 5 and 2? I think that's right, 5 and 2. Now this one's a little bit more involved, but really not very difficult. What can we factor out of both of these terms here? 3. Open x squared minus 25. What do you notice here? Don't everybody say it at once.
It's a conjugate.
Excellent, a conjugate. Okay, so this equals, on my screen this looks real small. Can y'all see this okay?
Yeah, it's fine.
Okay, good. X minus 5 times x minus 2, right? That's this. Now, this one we have 3. Don't forget about the 3 up here. Now this is a conjugate, so it's going to be x plus 5 and x minus 5. Right? Right. The x minus 5s cancel out. And what do we end up with? X minus 2 over. Now we're going to go ahead and do the distributive property here. 3 times all this misery here is 3x plus 15. Is there anything else we can do there? No. Let's see. What else is there? Okay. Okay. Next time we're going to do linear inequalities. What fresh hell is that, huh? Everybody okay with this? This stuff is here is not going away. You're going to see this. Maybe not forever, but you're going to see it quite a bit. Any questions?
Professor, when is our next quiz?
I'm sorry?
When's our next quiz?
I think it's on there now. Isn't
Oh,
it?
okay.
Isn't it? I don't know. I do those things over the weekend and I drink while I do it. So, I have.
Okay, don't worry. I'll take it.
I think it's on there, but maybe not. I may put one up tomorrow.
Okay, great.
Then again, maybe I won't. Depends on how I feel. No, I'll probably put you one up. I want to see, because what that does is it tells me how I'm doing, whether I'm stupid and not getting across or whatever. But I would like to I try to keep these things real small because I know that in your college class, don't y'all do my math lab?
Yeah.
And it's real, isn't it real long?
Yeah, it is.
Yeah, I'm going to try to not make this stuff very, very difficult and very long. Okay, I'll see you all Thursday. Have a good time down there in Bolivia. Don't worry about us here,
Thank you. Have a good time. Bye.
Igualmente, gracias. Okay.
Thank you. Bye.
I have no idea what that means, but it sounded Y'all
That's
take
a good
care.
Spanish.
Bye-bye.
Bye bye.
Bye, Professor.
Bye-bye.